Hello and welcome to part 3 of our OpenCV and Unreal Engine project. Today we're going to be adding a scene reader and a player reader, so we'll be able to capture basically anywhere from inside the game scene, as well as a player screen, send that to OpenCV, do some edits, and send that back. In order to do the player part, we're going to need Slate. So the first thing we're going to do is go to our build file and uncomment the Slate part, so that'll be included in our file. Now I've changed the name of my OpenCV reader class, well, to OpenCV reader instead of camera reader, because I want it to be more generic instead of just being able to read cameras. If you do change the name of your class, make sure you go to your project source files and just regenerate Visual Studio project files. Otherwise you might have trouble building. The compiler will still be looking for your old file names if you don't regenerate your Visual Studio project files. So that's right there. In the header file, the first thing I want to do is add a scene capture component. And we're also going to get rid of this root component. We can just use the one that comes with the actor for the root. So we'll switch this with a scene capture component and call this scene capture. We'll be using that, you probably guessed, to capture the scene. Since we have a few different modes for our camera, I actually want to make an enum for that. So here we're going to have our camera mode. That's the one we've already made. Then today we're going to make the scene mode and the player mode. We're also going to need a place to store the enum. So we're going to store our input mode that we just made here. And I'm also going to store an enum for our texture render target format. In the future I want to create the render target at runtime instead of having the pre-made ones that we're going to be using for now. And then down here for our camera materials, it's no longer just going to be a camera reader, so I'm going to replace most of these, and instead I want these ones. So we still want our media player and our media texture, just not camera media player and texture anymore. This will allow us to bring in more generic like videos if we want, instead of just the camera feed, and still use the same media player. We have our render target. We're now also going to store a 32-bit render target. So this guy's for 8-bit color, this one's for 32-bit color. We have a render target for the player screen. This one is going to be specifically used for helping to draw our OpenCV results back to the player screen. We have our camera raw material still. This just makes it a lot easier to grab the raw footage from the camera. We have our material post. No matter what mode we're in, we're going to be using this to draw our results to whatever has our post material on it, basically. And then we have a material render target. This material can take in basically any render target, so we use it to switch between drawing different render targets to a material if we want. We changed our texture 2D to be OpenCV texture 2D. This is where we're going to draw most of our OpenCV results to. Won't again matter what mode we're in, so it's no longer camera, it's just pure OpenCV. We still want our color data. In blueprints we'll start using this on next video frame properly. We only hooked up into tick last time, which is fine for the demonstration, but we actually want to be able to control our frame rate, which we already have it set up to do. We just weren't using the delegate, instead we were using tick. So and that's going to be really easy to fix. And then speaking of delegates, we want to catch the back buffer delegate when that's ready. That's essentially what's drawn to the player screen, so we'll catch it, we'll do our OpenCV stuff, and then we can either send that to a different screen to display our results, or we'll create a bool that'll be applied to player screen. We'll grab that right now. And then if this is true, we'll actually send the OpenCV results back to the player screen, so the player is going to see our OpenCV results, not the regular results, if that makes sense. And then lastly for the header, I'm just going to add a few control files. Most of these we're not even going to fill in today, but you'll see what they're obviously what we're going to do is just they're going to help us switch between our different modes. So this will, and when we enable a mode, we'll change our enum we've already made to represent the mode that we're in. And then there's a few other functionality we'll probably want to put in when we'll be switching, like what render targets are active and whatnot between the different modes. They're all set up slightly differently. So these will all help with that. Some of that we'll be setting up in blueprints just for today. And then one last function we need before we go to our C++ file, get color mode CV. This will just translate our color mode from our render target format there to something that OpenCV understands. And then yeah, that's it for the header file. So we'll switch over to C++. For the constructor, we've changed how we're working our root component. So now we're just going to use the built-in root component pointer that comes from the actor. And then here's our old screen component, both our raw and our post. We'll properly attach these to the root component now, so that should fix our weird pivot point that we have in the Unreal Engine, because before we weren't properly attaching our components. And then we set our enum. We'll default to camera mode because that's the one that's already set up and working. And then here's our color mode. We're defaulting to 8-bit color. That's all that we have functional right now as well. Later we'll be able to handle 16 and 32-bit color, but for this example we're just going to stick with the 8. And then these are basically all parameters we used to have, just some of our basic video settings. So then now down on begin play, we have to update wherever it says camera texture. This should now be OpenCV texture. And this will just be our render target. I also want to update our OpenCV functions here. This is now going to use a get color mode. We'll make that function get color mode. This get color mode function, this will later help us switch between our color modes. Right now I'm just hard coding back to our 8-bit color again, but in the future you see we'll get our 32 and our 16-bit working. Now we're going to optimize read frame a little bit. This section here we're going to actually wrap in a render call. So if we replace our read frame function with our new one, we now need at least one of these two render targets to be true, and we of course need our OpenCV texture to write to it. This part here is basically the same, just we pick which render target we want to use based on what mode we're in. And then all our OpenCV stuff down here hasn't changed. We're reading the pixels from the render target. This part's updated a little bit because we're now getting our color mode based on the input color mode, but right now this will always return 8-bit because we haven't made the other bit modes work yet. Then we convert our mat again and show it to the OpenCV display if we want. Then here, this area should be a lot better now that we've wrapped it in a render command. This should speed things up a little bit for us. The data inside the command is all still the same though. We're still locking the texture and then writing our new render data to it, unlocking it, updating the resource. Then we still need one new major function. This is going to be our back buffer delegate. So here this is going to get called when the player frame's ready. It'll come in on the back buffer. So we capture that and then we're going to send that to our OpenCV. And we capture that just by sending it to our 32-bit render target, and that's why we pick the 32-bit render target up on our read frame. And we copy it right here. So this is where the render target, we catch it, copy it over here. And then if we want to actually display that on the player screen, here we'll use that other render target. We're going to write our OpenCV data to that. And so we'll just copy that back to the back buffer, and then that'll display our OpenCV changes on the player screen itself. So that's pretty cool. And then this is also happening on a rendering thread, so our performance shouldn't be too bad. Then one last thing for our C++ file, we just have some utility functions. For the most part, they're blank, but they'll be useful later for enabling and disabling our different camera modes. So here we just have some functions that'll help us enable and disable our different modes. and as well as some functions that will help us with our camera mode, our next camera, and our next video track. Looks like I haven't actually declared these yet, so we'll declare these over in the header real quick, and then we should be ready to move over to the engine and do stuff inside the engine. And we'll add those quick. Save everything, and we should be good to build. So over here in the editor, we've made a new blueprint based off of our OpenCV reader class. We want to update some of the names of our assets here. They're not just going to be for the camera anymore. So this, for instance, is going to be an OpenCV media player. But for the most part, most of these names are going to go from camera to OpenCV. So this here is our OpenCV render target. I want this to be OpenCV as well. We actually do still want material just for the raw camera footage, but it'll be more like media raw instead of camera, because it won't necessarily be footage from the camera, but it will be stuff coming from our media player. And then the last one here for post, this will always be our post material regardless of our mode, so it's just OpenCV post material. And then I'm just going to duplicate this. I want one more material. This is going to be the one we used to draw back to the player. And for that we need two more render targets. One is going to be our 32-bit. So on the 32-bit one, to make sure we're using the same data that we're going to get from the back buffer, we want to make sure we select this one, the RGB 10A2. That's the same format that the back buffer sends us, so unless we want to have to convert to a different type, which in this example we're not, so we're just going to select the same one that we get. So just, yeah, make sure you select the right one there. But this one's for the player, because the 132-bit will take the player's screen in, and the other one will be the player render screen out. So one's the data that we're getting before we make the changes, and one's where we're going to send the data after we make the changes. So for your OpenCV player material, just drag the render target in and send that out to emissive. And save it. We'll just check our other materials. For this one, I'm remaking all the materials, so texture, sample parameter. This is going to be our OpenCV texture. So any changes we make to OpenCV, we write to that texture, and then we can grab them from this material. We'll be setting this texture up in our blueprint nodes in just a minute. I also like to set this one to the ceramic tile. That way you'll be able to tell if the texture is failing to be applied, because you'll see this like very bright pink checkered color instead of your input color or your output from OpenCV. And then just for our media raw, that one's really easy. Just dragging the texture from the media player. That's why we have it, because it's It's really that easy if you have the material just for this one. Save. So that should be most of our assets set back up, and we're good to head into the main blueprint. We got our 3 render targets, our 3 materials, and our media player with its texture. So now we'll go into our main blueprint. Now we want to bind all these. So we want to make sure we set the right one. So that's our render target. This one's our 32-bit, and this one's our player. So here in our blueprint editor, we're just going to get rid of those, and we're going to paste in most of our old logic, create our missing functions. Now down here I've created a couple of functions that'll just validate our camera and our track ID. We want to bind these to the proper delegates we made in our C++ file. So our camera ID, and our track ID. So up here we'll replace this. This is our on next video frame because we're using that instead of tick now, so that we can set our refresh rate manually. Just hook that in. So yeah, we're not using tick here. This is what used to be hooked up to tick. For begin play, we got to reset up our materials. So the post one is just our post material. Then the raw footage one, that's the one that we call OpenCV player. It's going to have whichever render target we're using sent to it. Now because we have the different modes, we switch on the enum here and enable whichever mode we want. There's a bit more going on to the camera mode, but that's the one we set up last time, so that should all be pretty familiar. We actually have to make these really quick. So we'll start with render camera. Camera map raw is wrong. Instead we want get material camera raw. We just changed the name a little bit there. Enable scene. So when we enable the scene, we got to use the scene capture component. So we have a few things we set up there. Make sure we set our material. Everything else. Got to make sure we change our texture name. We named it OpenCV texture now. And this is where we set which render target we want to use. That's why we have to make sure we make these enable screens. For the camera mode, drag that back in. We have a few variables we got to update. We want to get material camera raw. We just changed the name a little bit there. Screen raw. We'll set the camera raw. And then we want to set that to be our raw material. Make sure you update the name. Over here, this is our OpenCV texture. Good. Still got to enable player mode. Yeah, this one's really easy. Make sure you still got the right texture names. So this one again, we got to update the texture. OpenCV texture. File, save it. Watch it go save all. Back on the main event graph, we just have one more texture parameter to update. Instead of texture, it now says OpenCV texture. So we'll fix that. Otherwise, our texture won't write to the right spot. And then on your materials, you're actually going to want to make sure you promote this to a variable and also name it OpenCV texture. That way we can update which render target we're sending to this material. But other than that, we should be good to test it out. So you can drag out your player. Then the camera mode should already be working. So you can just hit play. So then to change modes, we can just select our input here, go to scene, hit play. You can see our scene comes up here. If we want to see the difference between OpenCV, we'll set our multiply and our brightness. So I'll do multiply 2, brightness minus 25. And if we hit play again, you can see the effects between our regular input and our OpenCV. That should be working as well. If we head back down, now we can go to player mode, hit play, and you'll see we're affecting the whole screen because we're grabbing the render capture. So oh, we should change our apply to player screen boolean to be public so we can change that. But if we set that to false, then our effects won't show up there. If we turn the multiply off, it'd be a bit better. Yeah, so there we go. Our camera reader can now be changed between our 3 different modes. We can go camera mode. We get our camera. There's our camera. So that's it for this video. Don't forget to like and subscribe if you want to see more of these Unreal and OpenCV videos. And we'll see you all next time. Take care.